Program 8 calculation of DFT and IDFT by FFT method, that is by using fast Fourier transform method. In the theory class, we have already studied 4 types of FFT algorithm, that is radix 2 DIT FFT. Next you have studied radix 2 DIF FFT. Then again we have studied radix 2 inverse DIT FFT and radix 2 inverse DIF FFT. All the 4 methods is already covered in the theory class. When the MATLAB programming, I will be explaining only the radix 2 DIT FFT method. So as we have seen, we are giving only one input for the fast in the FFT algorithm. That is by we have done it by using a butterfly figures. So x is equal to input, enter the input sequence. Since we have only one input, I will be just writing the one input, that is enter the input sequence. Next, I want to display the figure. Since in my program I have 4 figures, I have given it as subplot 4, 1, 1. That is 4 rows will be there. That when we see the figure, you will understand clearly. Next, you have only 1 rows, and this last one indicates the first figure. So in the figure, your first figure indicates the input sequence. Next, we will describe that figure. So since it is in the discrete plot, I will be giving stem. Then I have x label as time, y label as amplitude, title of that particular figure is input sequence. Next, I have to perform the FFT. Since in the MATLAB FFT is an inbuilt function, by default it will perform the operation. So x is equal to FFT of x. See the difference here. This x and this x should be different. One I have denoted as capital X and other x I have denoted as small x. Next, I want to display this particular x answer. So display x. Now, as we know that in the butterfly figures, whatever answer we are getting will be having the real part as well as the imaginary part. So, real part and imaginary part in the figure will not be displayed together. So, I will assume I will give 2 separate figures for that. That is subplot 4, 1, 2. That is the second figure will display only the magnitude of the plot. Only the magnitude of the answer. Similarly, again I have stem and magnitude, x label, y label, and title is magnitude of FFT sequence. Next, my third figure will give the angle. So it is a stem angle, x label, y label, and again title is imaginary of the sequence. The final answer, I have to check whether my answer what I have got is same as that of, if it is correct, I need to cross verify. That is why I am performing the inverse FFT. So XR is equal to IFFT of X. That means when I perform this particular operation, this XR will be same as that of the input sequence. Only if XR will be equal to your input sequence, that means the answer whatever we have got, capital X answer what we have got is correct. So that will be displayed. XR is equal to 4, 1. My last figure will be same as that of my input. X label, Y label, and title is IFFT sequence. Now, after saving the program, we'll run the program. So, I'll be using the 8-pointer FFT. So, my input sequence, I'll give it as 1. So, I'll be using giving 7 1 C 1 2 3 4 5 6 7 7 ones and 1 0. Close the bracket. Enter. So, once you enter it, you will get the figure. We'll see later. First, we'll see the sequence over here. So, first you give the input sequence 7 ones and 1 0. So, the first what we are performing is FFT. So, when you do the theoretical calculation by using a butterfly method, you have to get the same answer. Your real part is 7 and imaginary part is 0.1. Minus 0.7 minus. In the same way, you will get all the 8 answers. all the 8 answers you'll be getting till over here. Now XR. What is XR? I have told you that is you're performing the inverse DFT or inverse FFT, right? Inverse IFFT of the X we are finding out. So this will be same as that of your original sequence. So you'll be having 7 zeros and 7 ones and 1 0. Now we'll see the figure. So in the figure we can see over here, this is my original first figure is my input, that is 1 7 ones and 1 0. Then I have the magnitude part and imaginary part. So 0 point something, you first value you're getting it as 7 my plus 0 or some value you're getting. So this will be 7, this is 0. Similarly here you're getting 0 point some value, here you're getting minus. If you want, I'll check over here. It is 0.707. In real part, you have root of a square plus b square. Magnitude part, we can just neglect magnitude. There won't be a negative part in the magnitude. So, we will get the figure in this particular way. Thank you.